Let's get started, please. Let's look at this here, please. From last year, you have this question here. I've shown it to the group already. It says, consider a simply supported beam subjected to a point load as shown below. That's this. Using Macaulay's method, I've said, don't worry about moment area method. Don't worry about double integral method. It's always Macaulay's method or what there? First principle method. All right, they said, determine the equation for, number one, the deflection curve of the beam. That's it here. So you have to determine the equation for the deflection curve of the beam, 10 marks. Maximum deflection, 5 marks. Rotations at support A and C, 5 marks. This question alone is how many marks there? 20 marks. What's the first we have to find there? Deflection equation. Okay. Let's get it done here, please. Let's get this done. I want you to compare and contrast. When it comes to solving this, what's our first task? The first task is usually to get what there? Free body diagram. And I said free body diagram is as simple as take off this man here, bring this down, call this reaction at A, RA. That's all. Free body diagram, take off this man here, bring this down here, becomes what there? RC, reaction at C. You have these two things. So you have RA, RC. That's your first task. Number two, we'll bring out the equation of static equilibrium, which says that the summation of vertical forces equal to 0. After this, next up, summation of vertical forces equal to 0, sigma summation F forces Y vertical equal to 0. And I said for this one here, I am choosing to say all upward forces should be positive. It becomes going upwards, this, and then positive. And I say some lecturers will prefer to reverse it. They will say downward should be positive. If you do that way still, we'll get the same answer at the ending. So nothing spoiled. Upward forces should be positive. How many forces do I have here? 3. You have RA going upwards, you have W coming downwards, you have RC going upwards. This man is going upwards, it becomes positive. So I have positive RA. This man is coming downward, it becomes what there? Negative. I'm having minus W. This man is going upward, becomes what there? Positive RC. It's equal to 0. So I have this. My task is simple. I'll take minus W. Over here becomes what there? Plus W. So this becomes what there? RA plus RC is equal to what there? W. Of course, in kilonewton. Yeah? Call this equation 1. As usual. What's my next task? Simple. Take moment about what there? This point. That's task 2. Taking moment about C. Taking moment about C. If I take moment about C, what do I have there? We have that sigma, the sum of M moment about C, it's equal to 0. And we said when it's clockwise, it should be what there? Positive. So positive moment or clockwise moment is positive. So first things first, I'm coming to see this point here. The first thing here is that this man here is going up like this. If I trace this, it's going up like this way. So here's the movement up this way. What you have here is what there? A clockwise movement. The force there is RA, so it becomes RA. The distance from here to here is how many there? L. So RA times L. Next up, you have W coming down. Trace the direction towards C. It becomes from here downwards towards C like this. Downwards towards C. So this motion like this is what there? And anti-clockwise. So it becomes what there? Negative. The force there is W times distance from W to C. What's your value? Becomes 3L all over 8 is equal to what there? 0. Of course, this man does not matter because it's at that point. So its distance becomes 0. All right, from here, I have RA into L minus this gives you what there? 3WL all over 8 is equal to 0. I have this. Move this man over here. We have that RE times L, it's equal to, this man comes over here, it becomes what there? 3WL all over 8. If you look at this, I have L at this point and this point, they can cancel out. So they are gone. This would cancel this. I'll have that RA is equal to 3W over 8. Arrow is a reaction or a force, and it should be in the unit as given here, which is kilonewton. This kilonewton. We have this. We've gotten the value of RA. Let's now get the value of RC. I'll now put RA into 1. Put RA into equation 1. From equation 1, this man here, you have that RA plus RC, it's equal to W. Okay, to get RC, move this man over here. We have that RC is equal to W minus RA. Have this. Am I too fast? All right. So RC is equal to W minus, what's RA? 3W over 8. So RC will now be equal to, I've said W and W, work with the numbers. I'll now have 1 minus 3 over 8. What do you have? 5 over 8. 5 over 8 times W gives you what there? 5W over 8. Of course, also in what there? Kilonewton. With this, I've got the value of RA as well as the value of what? RC. This was quick now, right? Yes. And this is what I'm trying to say. When you do the second time, the third time, it becomes very fast. You've gotten the value of the reactions. Please, after getting the value of the reactions, what's the next step? What's the next step? Section the beam, right? XX. All right. Please, where am I sectioning, please? Where exactly? Here? Here. Okay. So we said when it comes to sectioning, section it to the right so that it contains what there? It carries what there? All the forces. So from this left, I will section towards the right. I'll pick this point here, as we said in a previous example or previous class, here, such that this one here must contain all the forces. Well, except the last one. But it should contain all the forces. That was the concept. And we said, call the distance from this to the left end. Call it what there? X. So I'll call this X from here, up to this point. Call it X. All right, so we have this. What's next in there? Take moment about what there? X. So write it there, please. Taking moment about X, or taking moment about X, anyone? Taking moment about X. I will say we call it what there? MXX. MXX. So what's MXX? MXX, it's equal to, that's moment about the XX axis, my bisection. When you do bending sections in beams, you do MXX and MYY. MXX, you're bisecting the vertical like this. MYY, you're bisecting what there? The horizontal. Very nice concept like this. All right, let's proceed. Take moment about X, please. That's about this point. This point here. So these two forces, 1, 2, are coming here. First things first, this man RA goes up like this and then comes this way. Right? Up like this way. This is what there? A clockwise movement. So it becomes what there? Positive. So it becomes RA. Please, distance from here to this point is what there? X. It becomes RA times X. So I have RA times X. That one is done. Next up, this one is coming down. So down this way. This direction is what there? Anti-clockwise. So it becomes what there? Negative. What's the force there? W W into, please check. Distance from W to this point, that's B to here. What's the distance? Sorry? Right, of course, so it becomes this one here minus this one here, Abi? Yep. So from here to here is X, and from here to here is 5L over 8. This small distance becomes the total minus this one. So X minus 5L over 8, as we discussed. So it becomes X minus 5L over 8. So you have this. Okay, so we have this. So what next there? Next is to do what there? Equate mxx to what there? EI, the squared y over what there? The x squared. Or let's put the value of RE. Mxx is equal to, let's put the value of RE. What's RE there? 3W over 8 into what there? X minus what there? W into what there? X minus 5L over 8. All right. So our next task is to equate. Equate mxx to EI, the squared y over the x squared. So we have this. Let's do the equation. It becomes this one here is equal to this. So EI, the squared y over the x squared is equal to this one here. 3W over 8 times x minus W into x minus 5L all over 8. So we have this. At this point, what's next? This is how fast we are. If I tell you I can finish under 15 minutes, I'm not kidding. It's just the one when you do it for the first time, your brain is like, this is looking complex. No. If you actually master it, 15 minutes, you're done with this thing. On a normal time, your time required for this question is maximum of 30 minutes. Maximum of 30 minutes for this question. For each question, maximum is 30 minutes. Right, but you can finish one in 15 minutes. You finish more second in 10 minutes. You finish chef for like 20 minutes. Why? Finish in 1 hour. they'll just arrest you. Machinery. They'll just arrest you one hand. All right, so we are here. We are here. Next task is integrating. Right? My record. Is it recording? Integrating. Please, let's not waste time with the integrating. Let me go straight to the point. If I'm integrating as we did in our previous example, my first task to do what there? Bring the constants outside, Abi. So let me save my time. It becomes what there? EI integral of what there? The squared root of what there? Dx squared is equal to, this one will be outside, it's a constant. So it becomes what there? 3W over 8 integral of what there? X, okay? Minus, this one is outside, W integral of what there? X minus 5L over 8. All right. Do you need this man again? Nope. But let's get this done here. So what do you have here? EI dy dx is equal to, what do you have here? 3W over 8 integrate x here. What do you get there? X squared over what there? 2. Right, so it becomes x squared over 2 minus, so minus W. I want to integrate this man here. You know what that means? Bringing what there? Square bracket. Bring a square bracket. So I'm having square brackets into x minus 5L over 8. All what there? Squared. All over what there? 2 What's the final thing there? What's the final thing there? Plus C1, or constant of integration. This, you now have plus C1 constant of integration. Proceeding with this, I have EI dy dx. It's equal to, what do I have here? 3w over what there? 8 times 2, 16 into what there? X squared minus, what do you have here? This one comes down here, becomes what there? W over 2. So I have W over 2 into what there? X minus 5L over 8 all squared plus C1. What's next? Integrating what again there? Again. Integrating again. Okay? Integrating again, I have EI, the integral of dy dx, it's equal to, this man is outside, 3w over 16, the integral of x squared minus, keep this one outside, w over 2, the integral of what there? X minus 5L over 8, or what there? Squared plus the integral of what there? C1. Now integrate C1, so I have this. Look at that. I hope you're just copying this last note. You guys are just you're copying notes. Hope you are listening. I'll just be copying note. The copy CRK notes here. All right. You have any question, please ask, go. From here, I have EI. What do you have here? Y is equal to, what do you have here? 3W over 16 into what there? X, 2 plus 1, 3. So 3 all over what there? 3 minus W over 2 into, what do you have here? X minus 5L over 8. 2 plus 1, 3, all over 3. This plus, if I integrate C1, what do I get there? C1x. So plus C1x, then plus what again there? C2, the constant of integration. What next? Using boundary conditions. See how fast and how easy this can be. Assuming I was solving myself without talking, I'd have gone further than this. Because I'm talking and I'm cleaning the board. So I am this slow, but we're way faster than we did in the first example. So when I say this is actually easy, they're easy. They're easy. All right. Simplifying is what you have there. We have EIY. It's equal to, whatever, 48, right? Yes. So I'm having what there? Okay. Instead of that, 3 can cancel 3, right? Yeah, lowest step. So it becomes what there? W over 16 into what there? X cubed. That's it. So this cancels this. Come here, I'm having minus W over 2. Nope. Over 6, please. All right? 3 comes out here. So 2 times 3 gives you 6. I'm left with what there? X minus 5L over what? 8. All cube plus C1x plus C2. I have this. What's next there? Using boundary conditions. Right. Using boundary conditions. In the boundary condition, there are 2 boundary conditions. What's the first one there? X equal to 0, y equal to 0, C2 equal to 0. Right. Yes, always like that. X equal to 0, y equal to 0, C2 0. Always like that. Condition 2. What's condition 2? X equal to L, y equal to 0. Good. So X equal to L, y equal to 0. So I have this. So I will now substitute this. Um, let me to which of them? This equation, right? You said this equation is called what's this one called? Deflection. This is the deflection equation. What's the other man? This one here. It's called what there? Slope equation. Right? So the one that has the y over the x is slope equation. The one that has y is deflection equation. So substitute into deflection equation. Substitute into the deflection equation. What do I have there? What do I have there? EI times 0 now. EI times y is 0. It's equal to W all over 16 into x cubed. X is L. That becomes what there? L cubed minus W over 6. W over 6 into x. X is L. So it becomes L minus 5L over 8 all cubed plus C1x. C1x is what? L plus C2. What is C2 is what there? 0. So you have this. Simplified is what you have there. This gives you 0. It's equal to this gives you WL cube. W times L cube. WL cube. All over what there? 16 minus W over 6 into, this is literally 1 minus 5 over 8. What do you have? So this is 1. So 1 minus 5 over 8. You have what there? Huh? 3 over 8 becomes 3. There's an L. So 3L over 8. All to power what there? 3. So when you do L minus 5L over 8, I've said what to do is simple. The number here for L, or the coefficient, is 1. For this other L is 5 over 8. So if you punch 1 minus 5 over 8, you get 3 over 8. Attach the L, then cube. Plus what? Where? C1L. All right. Let's expand this. We'd have that 0 is equal to, what do you have here? WL cube. WL cube over what there? 16, okay, minus W over 6 into, please help me expand this, please. 3 cube is what? 27. 27L cube all over 8 cube is what? 512. 512. All right. 3 cube, 27, L cube, 8 cube, 512. What are you left with here? Plus C1L. Zero, it's equal to WL over 16. Have WL cube, thank you, over 16. Okay, so let me multiply this. So minus, what I have here is W times 27 times L cube. That's what there. 27 WL cube. 27 WL cube all over. For denominator, I have 6 times 512. What do you have there? Sorry? 3072. I told you to go get white Casio calculator. So when you come here, you start looking for LCM, Abi. Plus C1L. That's why when people tell you instruction, you have to listen to them. I know what I'm telling you. And these ones are still easier examples. When we come to UDL, you'll be seeing very large values. There's no way you can start doing, what's it called? LCM. No way. 0 is equal to, so please help me. They are both WL cube, WL cube. And I said, this is a pointer that what you're doing is what there? Correct. You can see there. Not you're having, some of you get 3WL squared and WL cube. You say, okay, Mike, just change the 2 to 3. For some of you know yourself. 3L squared over 6 minus WL cube over 17. 2 and 3. You know hard now. Now 3 and 3. You're wrong with it. Check yourself, oh. Check yourself. Any way is a way, as they say it. All right, so the numbers will now be 1 over 16 minus 27 over 3072. What do you have? So it's 55 as numerator. Bring in the WL cube, all over what? 1024. All right, so I'll have this. All right. So it's a simple, take the number here, 1 over 16 minus 27 over 3072. You have 55 over 1024. Attach the WL cube, and that's all. Plus C1L. Move this man over here, minus 55 WL cube all over 1024 is equal to C1L. From here, you can see that L will cancel what there? L cube will give you what there? L squared. So what do you have here? Minus 55 WL squared all over what there? 1024 is equal to what there? C1. We've answered the first question. We've almost answered the first question. The first question is to find what there? The equation of what? Deflection. You can't stop here. You have to find the value of C1 and C2. Put C1 equal to minus 55 WL cube all over L squared all over 1024 into the deflection equation. If you look at this, this is the deflection equation. EIY equal to this minus this. Where I have C1x, I'll take up the C1 and put the value, then attach x. C2 is 0. Okay. So C1 is minus 55 WL squared all over 1024. So C1x, this plus C2 0. I've gotten my answer for the first one. See how fast we are. So the A part has been solved. So this is the A part where you're asked to find the equation of deflection. A part has been solved. What's the B part? B, we have to find the equation. Check now, it was equation 4, right? Please confirm, that's it, all right? Please. Finding maximum deflection and finding equation for maximum deflection are two different things. Equation of maximum deflection. How do you find the equation? What's the condition? At maximum deflection, the slope, dy dx, is equal to what there? 0. Right. At maximum max deflection, please write in follow, write in follow. If not, you tell me what max means. So, no, you tell if max is somebody's name. Write in follow. At maximum deflection, slope, that's dy dx, it's equal to 0. Please help me recall the slope equation again, please. EI dy dx, EI dy dx, is equal to what? 3w over 16 into x squared, minus w over 2 into 5l over 8 to power 2. Hold on, it was plus c1, right? Hold on, it was plus c1, right? So what's the value of c1? Minus 55 wl squared over 1024. So it's plus c1. Was there x attached to it? So this is the value of c1. So there was no x. That's this. So look up, please. This is my deflection equation. We said this in there. This man is 0. So to save my own time, I'll just put 0 here. Is that okay? The same deflection equation, and I'll put 0 here. So take this man off, put 0. Put 0 here. So 0 will be equal to, this gives you what there? 3w over 16 into what there? X squared minus w over 2 into, we'd have to expand this. By now, you should know how to expand this from a previous example. This should give you what there? X squared. Then use 2 times this times this. 2 will cancel 8 to give you what there? 4. So that becomes what there? Minus 5 times L times this gives you what there? 5L over 4, right? I did a shortcut now. Shortcut is that, first of all, square this. X squared is x squared. Then use 2. 2 times what you have here, x, times what you have here, minus 5L over 8. That's a shortcut. 2 cancels 8 to give you what there? 4. So it becomes minus 5L over 4 times x. Minus 5L over 4 times x. Then finally, square the last term, including its sign. Minus squared gives you what there? Plus 5 squared gives you what there? 25. L squared gives you what there, of course? L squared all over. 8 squared gives you what there? 64. I have this. So squaring this bracket, I have this minus 55 WL squared all over 1024. So I have this. At this juncture, let's use W over 2 to multiply through. I'll have that 0 is equal to 3W over 16 into x squared. I have this. Use this to multiply this. That gives you what there? Minus W over 2 x squared. Okay? This and this. Then this and this. Minus minus plus W times 5L. 5WL all over 2 times 4, 8. Bring down the x minus plus minus w times 25l squared. 25w squared. 25w squared all over 2 times 64, 128. Then bring this man down here, minus 55 WL squared all over 1024. All right, so I have this. Okay. All right. Let's take like terms. Or sorry, like terms anyway. So 0 is equal to. So if you look at this, I have x squared, and we have a particular w. So we work with just the coefficients. So in this case, for x squared, it becomes 3 over 16 minus 1 over 2. What do you have there? Minus 5, then bring back your w, minus 5w over 16 into what there? X squared. You have this. For the x, you don't have an issue. It's just 1. Becomes plus 5wl all over 8 into what there? X. For this one, observe that I have wl squared. So it just becomes, just punch minus 25 over 128 minus 55 over 1024. Punch that, what do you have there? Minus 255 over 1024. Bring in the alphabet, which was what there? WL squared. So I'll bring back the WL squared. So you have this. All right, so at this point, we now have a quadratic equation, which we must solve. We'll be using the quadratic formula. So we'll have to get the value of what there? A, B, and what? C. What's A here? Minus 5w over 16. What's B? 5wl over 8. A is this thing attached to x squared. B is this thing attached to x. While C, what's C? Everything here, including sine, minus 255 WL squared all over 1024. We have this. Okay, guys, so we have this. So let's use the formula. The formula there is what? Minus B, recall it. So you can recall it here, but I don't think that's necessary. Minus B plus minus root B squared minus 4AC all over what there? 2A. So X will be equal to minus B minus what's B here? 5WL over 8 minus B plus minus root B squared. B squared becomes this one here, 5WL over 8B squared minus 4AC minus 4 into A. A is this one here, minus 5W 16 minus 4 A, then C. C is this one here, 4AC. C is minus 255 WL squared all over 1024. All right, B squared minus 4AC all over, this is all over 2A becomes 2 into A. What's A there? Minus 5W all over 16. We have this. All right, let's see this. What do you have here? Have the x is equal to, what do you have here? Now this stuff looks messy, right? It's really, really messy. So do you work with decimals instead? Or let's try to use fraction until we get tired. Then we'll now switch to decimals. Okay? Works like that. So I'm saying this becomes this and this minus 5 WL over 8 plus or minus square root of 5 squared, 25, this and this, W squared, this and this, L squared, 25, W squared, L squared, all over this and this, 8 squared is 64. All right, next up, minus minus plus times minus minus. So minus into 4 times 5, 20. 20 times this, what do you have here? 20 times 255, what do you have? 5100. Huh? W times WL squared gives you what there? W squared L squared comes W squared L squared all over 16 times 1024. What do you have? 384 all over. From here, please observe that 2 cancels 16 to give you what there? 8. So I have what there? Minus 5W over 8. This will be equal to, what I have here is minus 5W L over 8 plus or minus the square root of, observe I have so I was saying, observe that we have W squared L squared, W squared L squared. So just focus on the numbers or the coefficients. That becomes 25 over 64 minus 5100 over 16384. Punch that. What do you have? Sorry? 325 over 4096. This, bring back the alphabet, W squared, L squared. Please check if it's a perfect square, 325. Does it have a square root? No, it doesn't. What about the denominator? Does it have a square root? How many? Okay, so this one will be like a sword, right? Root something, so it will be all over. Give me this, what do I have? So since we have this, look up please, look up please. These two are not perfect squares. In this point, now we have to switch over to what there? Let's use decimals. Before then, please check 5 over 8, what do you have? 0.625, exactly that. Now listen, listen. I'm saying this. Listen. I'm saying this. For this case here, what we'll do is simple. Observe that this one's here. This one has a good square root. This one has a square root. This one does not. So I'll now have to switch to what there? Decimals. Before then, give me minus 5 over 8 in decimal. What do you have? Minus 0. Okay, Okay, before then, let me just bring this. Hold on. Just keep it pending. Let me just write this here. Minus 5w over 8. Please know why I'm doing what I'm doing. That's the thing there. So here, x will be equal to, I would now have to switch all of them to decimals. Why? Because this one here is not a perfect square. Let's start with this. Minus 5 over 8. You have minus what there? Minus 0.625 into what there? WL plus or minus. Now, here's the thing. If I take the square root of W squared L squared, I'll have what there? WL. Now, you give me the square root of 325 over 4069. Take the square root of this ratio. What do you have? Or this fraction? What do you have? 0.2. Follow the number of decimal places there. 228. That's 282, right? All right. So if I punch square root of 325 over 4096, I should have 0.282. Bring down root W squared is W. Root L squared is L. This all over. This all over. This gives you what there? Minus 0.625 W. Right, so we have this. All right, so we have this. At this juncture, we can now say x is equal to minus this plus this all over this, which is minus 0.625 WL. Let's take the plus 0.282 WL. So this all over this minus 0.625 W. So it's simply equal to this plus this all over this, or this minus this all over this, or minus 0.625 WL minus 0.282 WL all over. This gives you minus 0.625 W. All right, so you have this. Proceeding, we now have that x is equal to, please add this one for me. What do you have? Just do minus 0.625 plus 0.282. What do you have? Minus 0.343. Then what again there? WL all over minus 0.625 W, or x is equal to, now you now punch minus 0.625 minus 0.282. What do you have? Minus 0.907. That's all. Bring in what's there? WL, right? WL all over. Bring in denominator minus 0.625 W. First things first, this W will cancel this W. So x is equal to minus cancels minus. So you have 0.343 divided by 0.625. What do you have there? 0.54. 54 what? 5488. 3 DP or 2 DP? Now hold on. I used 3 because I was solving. When you get to your final answer, use what there? 2. So I'll use 0.55 into what there? L, or x to be equal to minus cancels minus, W cancels W. What do you have here? 0.904 divided by 0.625. 1.45 into what there? One of them here is wrong, right? Which is wrong? This is that this is another hard. Now it's just flowing easily because I've already told you how it's done. So from here, the value of x is always the one that has 0 point something, not 1 point something, not 2 point something. Because this value here is bigger than the span of the beam. So x will always be equal to the one that has 0 point something and positive. So it becomes this, it's off. In any case where you solve up to this point and you're having two 0 point something, 0 point something, the differentiating factor will now be one of the 0 point something will be positive and the other 0 point something will be negative. So which do you take? The positive one. All right, so therefore, max deflection occurs at x equal to 0.55 L. In the B part, we have to find what? The equation of what? All right, let's get that done. So I will simply put the value of x as 0.55 into the deflection equation. Let me tell you something here. Let me tell you something here, or let us leave it till the end, and I will tell you something. I think it's better that way. Let's leave it to the end, and I will tell you something. And what I want to tell you is this: in your solving, if you check the past question, they always like leaving the value of x in as a fraction, not decimal. They always like leaving the value of the maximum deflection as a decimal, fraction, not decimal. So what we'll do is I will solve this to the end and then we'll convert it to a fraction. And we'll use approximate value. I will share you another past question where you're asked to prove that y at a particular point is approximately. We'll tell you approximately. You see what I mean there? But until then, let's just use this this. So if you have to find the maximum deflection, if you have to find the equation of maximum deflection, we'll substitute x equal to 0.55 L into the deflection equation. Please help me repeat the deflection equation, please. EIY. In this case, I'll call it what there? Y max. I'm not looking for maximum. EIY or EIY max is equal to, what was the first thing there? Sorry? W over 16 into what? X cubed. X is what there? This, so 0.55 L all cubed. Okay, next up. Minus W over 6 into X. X is this 0.55 L. X minus what? 5L over 8 to power. Okay, so cube. What next? What's C1? Minus 55W L squared all over 1024 into X, Abi. So this man into X. Bring in X value. What's X value there? All right. So C1X. So you have this. So this is, let's just finish this up, and that's about it. So I have EIY. EIY y max is equal to, so let's get this done. How do we do this? To save time, can we just punch everything at once? Do you know what to do? Look at this, please. Look at this. To save time, let's punch everything at once. How do you do that? Look up, please. Because if you want to cube this, it will be too much. Or should you do it that way? Step by step. W over 16 into, give me 0.55 cube. What do you have? 0.1664. This L cube, please confirm it to L cube minus W over 6 into, please give me 0.55 L minus 5 over 8. So hold on, leave the L's. Focus on, just punch 0.55 minus, in bracket, 5 over 8. Minus 4.45, then L. Please confirm that's correct. Please punch 0.55 minus, I know why you're getting that answer. I know why you're getting that answer. You didn't punch correctly. You should punch 0. Let me see your calculator. So look up 0.55 minus, in bracket, 5 over 8. What do you have? Minus 0. 0 what? 0.75. This. Then what again there? L. All cube into minus, give me 55 times 0.55. What do you have? 55 times 0.55. What do you have? 30.25. 30.25. Hold on, please. 25. Then take what there? WL squared times L gives you what there? WL cube. WL cube. All over what there? 1024. Okay. I now have this as EI Y maximum. So Y max is equal to, please help me, please. From here is simply W times L cube. That's WL cube. Let me take it step by step too. This times gives you, this goes to this, that becomes 0.1664 WL cube, WL cube, all over 16, minus plus this, oh, before then, sorry. Minus W over, minus W over 6 into, please give me this one, please. L minus cube, that's minus times minus, plus times minus, minus. Please give me this man cube. What do you have? 0.0000422 what there? L. Not just L, but what there? L cube, right? Please confirm that. Minus cube is minus times minus times minus. Which gives you what there? Minus 0.075 cube is 0.00422. 0.000422. L cube is what there? L cube. I now have this as minus 30.25 WL cube all over 1024. Let's take all of them in fractions now, or in decimal. EI Y max is equal to, please punch 0.1664 over 16. What do you have? 0, give me like 4 dp. 0 0.0104. Will it get to 5 dp? All right. 4 into what there? W L cube. Is that okay? Yep. So this one is this. Minus minus is plus. So plus. Next up, W times L cube is WL cube. You're left with now 0.000422 divided by 6. Please punch that. What do you have? 0.000422 divided by 6. What do you have? 0.0003 zeros. 703. No, let's was 7. Then what's here? W times L cube. You see what there? WL cube. This value here is simply 0.000422 over 6. You have this. All right. Minus. Please give me 30.25 over 1024. 0.0295. Then what here? WL cube. They are all in WL cube. So I can have EI Y maximum is equal to, just give me 0.0104 plus 0.00007 minus 0.0295. What do you have? Minus 0.01903. This into what there? WL cube. So I have this. How do you get white max? What do you do? Divide both sides by what there? EI. Right? Divide by EI. Divide by EI. Divide by EI. So if you divide it by EI, it goes off, right? It becomes Y max. So please divide here by EI to cancel this. Y max will now be equal to what there? Minus 0.01903 WL cube all over what there? EI. This is the value of the maximum deflection or the equation of it. This. L cube over EI. And we can leave it here. But if you can put it in fraction, that's like the best. You can put it in fraction. That's it. What's that, Chief? What's the problem, issue? What's the problem? And so you have this. What's the C part? Equation of rotation rotation at the support is just RE and RC. That's for the C part. You have to find the equation. This is it now. This is an equation. This is not an answer because we don't have the value of WL or E and I. So this is an equation. The C part, you have to find the what? Equation of what? The rotation of the support. That's simply what there? RE and what there? RC. So RE, let me put this way, this. So we have that equation of rotation. RE. Please give me RE value. What's the value again there? (3W/8). What's RC? 5W/8. What did you observe? I did not put kilonewton. They should find what there? The equation, not the value. So I didn't put the kilonewton. I didn't feel it's necessary. Just like this man here. Y is supposed to be in what there? Meters. So I didn't put the kilo. So this is it. So that's the answer to this question. What do you observe? We are done. In the first one, we answered 2. Here we answered what there? 3. And we are faster. And that's the concept. The more you do it, the faster you become. There's no magic about it.